Hello everyone, my name is Austin Shaner and welcome back to my channel. Thank you so much for joining me today. I'm experimenting a little bit with a different format because my videos tend to be fairly long-winded, as you've already seen, and they're more of a conversation style rather than literal instruction. And so I thought maybe it would be best to have my face present in the videos because that way I'm talking directly to you guys and you guys are interacting with me, especially through the comments, which I greatly appreciate. And we can kind of go forward with that. So leave me a comment down below if you'd like to see this kind of format going forward. But otherwise, let's get to the video. So you kind of got a little snippet in the intro of what I'm working on today. So this is episode 2 of CAM in Fusion 360. And today we're going to be talking about the order of operations. And what I mean by that, again, which I'll go into much more detail later, is we need to pay attention to the progress of our part through the manufacturing process. So that way what we're doing in one operation doesn't end up hindering something that we need in another operation. And I thought that the best example that I have that I've worked with is mechanical keyboards. Now, many of you may not be really that familiar with mechanical keyboards, but essentially they're custom DIY made from scratch keyboards that you can put your own keycaps on, you solder your own circuit board, you can buy or make your own case, and it really allows you to fine-tune your comfort while you're working at your desk. And I'll show you guys the finished product near the end of the video, but let me show you why I think mechanical keyboards was my toughest project yet. Okay, so jumping into Fusion 360, let's take a look at what makes this model quite difficult to machine. So at first glance, this model seems fairly normal, right? You've basically got a rectangle and you can do a 2D pocket from this surface down to that surface, just kind of avoiding some pillars so that way my circuit board has something to mount to. Not terribly too difficult or dissimilar to the gift box that we just modeled or that we just did in the last episode. The challenge with this is that this keyboard sits at an angle. So if I look at it from the side, you can kind of see what I'm talking about. So we've got this surface, which is two parallel surfaces that are at about a 2.5 degree angle. And these two surfaces are perpendicular to those as well. So that means that when we machine this pocket, we need to be able to hold it. See if I can get this oriented correctly. We need to be able to hold it roughly like this so our z-axis can cut straight down. And so that means that we actually cannot machine this backside first unless we're able to hold that backside at a very specific angle. Now, I am not a particularly competent manual machinist, and so I wouldn't be able to set up the parallels or a sine bar or anything like that to get that angle dead on and machine it that way. So constraint number 1 that we're running into is we've got tapered and non-parallel surfaces, which means we're going to have to find a way to machine this side first. And then constraint number 2 is we need to be able to flip the part over and then machine this side after the first side is done. So constraint number 2 is two-sided machining, and also with two-sided machining, as if anybody's tried to do it, is you run into alignment problems. So you need to actually make sure that when you flip that part over, it's still perfectly centered on that on your machine, so that way everything lines up and you don't end up off like cutting skewed and ruining your part. So that's constraint number 2. And we'll go into detail about how I tackle these in a minute. Constraint number 3 is once we've flipped over the parts, we need to actually be able to hold on to those parts in both orientations, right? So if I go back to the first side, I need to be able to hold on to this part and still machine the entire inside here. So I know that I'm going to have to cut this from a larger stock. And that's not terribly big deal, right? Obviously, at CNC, we tend to cut from larger stock. But we need to not only cut from a larger stock, but we need to provide a way, like I said, in constraint 2, we need to provide a way to hold the alignment. And then constraint number 4 is that we need to be able to maintain our work offsets in both orientations. So what can happen, let me see if I can show this. So if I'm cutting in this orientation first, and I zero my work offsets to the X and Y, and then to Z, and then I cut down to this pocket, right? And then I flip the part over. So let me look at it from this angle. And then I flip the part over. Well, this is the edge that I had just zeroed off of, right? Let me flip it back and see if I can show you. So that was the edge that was over here before. Then we flip it over, and now all of a sudden my work offset is thinking it's on, well, it's still thinking it's in this corner, but that corner is now over here. So if I don't have my stock set up very accurately in my machine, well, then as soon as I flip it over, this corner might be a 1/16 of an inch too far this way or too far this way. And now I'm going to end up cutting into the boundary of my stock. So, or not stock, of my model, and ruin my part. So I need a way to flip this part and keep it symmetrical and hold on to the part and keep my work offsets in all orientations. So those are three pretty big constraints. Another constraint is that we're going to have to do some tool changes, right? Because we can do a flat end mill cutting into the top here, but on the back side, we can do part of it with a flat end mill, but eventually we're going to have to come in with a bowl nose or a round end mill of some sort, or like a radiused flat end mill, and smooth all these out with some 3D contours. So we know that we're going to have to at least have two tool changes, or sorry, at least one tool change. So this hole here is 1/8 of an inch, and I could cut this entire pocket with 1/8 of an inch bit, but then it would take a significantly long time to mill all that out with 1/8 of an inch bit. So I know that I would like to cut this out with at least 1/4 inch bit, swap over, cut these holes with 1/8 inch bit, flip the part over, right? Then mill out most of my stock with that same 1/4 inch bit, and then switch to a round over. So I'm going to end up having at least 3 tools. And I don't want to have, once I put one tool in the machine, I definitely don't want to ever have to take that out until I am done using that tool on all surfaces that I need to. And so that way I never have to re-zero my work offsets when that tool is still installed. So that's another constraint. And then as a bonus, I would like, this is my own personal constraint, but I would like to have this be a repeatable setup where I can come back in a week and make another one, or in a month make another one, and not have to worry about alignment or anything like that. I can just set it up again, run it, and be done with it. So those are some of the things we're going to need to keep in mind as we program the cam for this part. Now, just as a heads up, most of the programming in this model is actually very similar to what I showed you in the last video. So I'm not going to be doing a ton of cam programming in this video, but more so showing you kind of my thought process as I went down this, so that way you can apply those to your models and how you imagine those constraints and how you order your tool paths in a way so that way you can be successful from start to finish. So let's go ahead and switch over to the manufacturing workspace, and we'll start showing you how I approach this. So the first thing I did was actually create a little fixture. And what this allowed me to do, it actually helped me a lot, because the hole here, these 4 holes, are for dowel pins. And what that allowed me to do is basically have a fixture that I can drop down onto my CNC at any point I want to make this part, and maintain my alignment in the same spot on my CNC. I just install some dowel pins, throw this fixture on, and I'm basically set up and ready to start cutting. So that's a cool little feature. The second feature is I gave myself a dowel pin here and here, so that way I can then flip my part, and I'll show you that in a second. The third feature of this is that I have a little recess here. Now this recess serves two major functions. First one is it allows me to go below my stock with the end mill, so I don't have to worry about if, you know, my Z is just not quite perfect. I can set my program to cut like a 30-second below and go all the way around. And then the final one, which is arguably the most important of all, is on 3 of my corners, I placed a fillet. And the point of that was that one of my corners I did not. And this corner, basically by applying the fillet there, it told me this is the corner I always zero all of my programs off of. I never have to zero my program off of my stock or my model at any point. I have the same fixed or known point on my CNC where all of my programs start, no matter what orientation the part is in. And so that's a really handy little trick that I did. So let me see if I can show you the stock that I made. So it looks like this. So what this allows me to do is basically I can cut my stock on the table saw to 5.5 inches wide by 15.75 long by, let's see, by 1 inch tall. So I can cut my stock to that size, and then I can just set it on my jig, and I can use these edges right here as alignment. And so that'll just get me roughly in place so that I know, as long as I center it between those or get as close to those edges as possible, I know that my stock is going to have enough material both on the left and the right in order for me to have full access to my model. Or not full access, but my model will sit inside that stock so long as I have that centered up. And then what I can just do is clamp down from the outside down onto the part and hold the part down for its first operation. So that's kind of how it's set up. Now these dowel pins, I will show you these in a moment, but essentially those are obviously so that I can flip the part. But when the stock is sitting on the fixture at this point, there's no dowel pins. It's just a square chunk of wood or rectangle chunk of wood. I get it roughly in alignment as close as I can get it, and then just clamp it down. And by modeling the stock this way, rather than what I did in the previous episode where I had Fusion create a stock for me, is I was able to model in these dowel holes so that way I would be able to machine those, and I didn't have to include those actually in my part. So this is just for setting up for the flip, but I didn't actually have to include that geometry in my part whatsoever. I just built that right into the stock. So in my first setup was actually for my fixture. So I can go ahead and show you that real quick. Let me hide the stock real quick. Okay, so the first one is just open that up. So I have a stock that's exactly the size. In fact, I believe I just used, I did fixed size box and I told it the size that I wanted it to be. And then I came in and I did a boring operation to mill out these holes for the dowel pins. And I kept the using the negative stock to leave from my previous episode, I fine-tuned that hole. So I set the hole relatively small, and then I fine-tuned that hole until I got the fit that I wanted on the dowel pins. So that way there was no slop in them side to side, but it wasn't so tight that I couldn't take the fixture off later. I didn't have to hammer the fixture on. So I had it so I could actually just take it straight off, but there was just enough slop in there where it was easy to take off, but I could still maintain nice alignment. And then I came in and bored these holes, but these ones I wanted to be tight, right? So I did the same thing where I left some stock to leave, and then I milled those down until I had a nice kind of press fit with the dowels, because once those dowels are in there, I don't want them coming out at any point. So that's why I kept those two separate these four separate from these two, because I wanted them to be slightly different sizes. Then I came in and just did a pocket operation to cut in the recess, and then I just cut my contour. And I didn't need any tabs in this particular, or I didn't even want any tabs in this particular case. So I ended up basically as its final pass was going around, I just put my hand on it and held it down, so that way I could, actually no, I didn't do that. Once the dowels were milled and they went far enough down into my wasteboard, I just put the dowels in there, which kept it in place, and then I just put a little pressure with my hand on top to hold it in place. So that's how I cut the fixture. So let's go ahead and hide that. And let's start working through this. So the next operation, let's show our model. Actually, here we go. So here's our stock. And the next operation is, I just only had one thing that I needed to do with the 1/8 inch bit. So I just took care of that right away. And you can see that my 0 point for this operation, even though I'm cutting into my material here, is on my fixture. So that's really important because all of my programs have to start from that corner. And so I just took my 1/8 inch bit and I milled out the holes. So if I go back to the design space, I milled out all of these holes. Go back to manufacturer. And then I did a tool change. So I just did a tool change right away because most of the milling on this part is going to be done with a 1/4 inch flat end mill. So I went to a 2D adaptive. So right now there's no dowel holes, even though it shows because it's modeled off my stock, the dowel holes haven't been cut yet. That's the last operation in here. So I did a 2D adaptive pocket, and I did a pretty deep pocket. I did, I think, about 1/4 inch, but I left a pretty light, let me see. I actually did a 0.1 optimal load at a depth, I want to say of about 0.25. That looks about right. And then, so that took me down to the surface of my pegs or my standoffs. And then I needed a separate operation to come down to the final depth, but avoiding my pegs. Now you'll notice when I modeled it, I actually came back after trying to do the cam and made some changes so that there's actually distance between the peg. There's enough distance between the pegs near the wall here that my 1/4 inch bit can actually get in between there without running, because originally I ran into a lot of cam errors because my bit couldn't actually get in between there, and so it was telling me, no, you need to do this with an 1/8 inch bit. So that's actually what all these recesses are for. Then I came in with a 2D contour, and I'll simulate this in a second so you can see it all at once. I came in with a 2D contour to kind of chip off this little edge up here. And then I did basically a finishing pass to come in and cut, to make sure all of these surfaces were at final size. And then I did a preliminary contouring operation, and I'll explain why I did that when we get down to the later steps. And then I milled in my dowel pins. Now, I actually didn't go all the way down. I don't think I can select it. Let me see if I can make this transparent. Let me simulate that operation. So if I go to simulate and I make the stock transparent, no, I actually did mill it down. Okay, I did mill it down all the way, I think. Let's see. No, I did not. Come back. Yeah, so I milled it most of the way through. That was enough of a height for my dowel pins to stick in all the way without bottoming out. But I did that for a good reason, because when I got to the other side, I milled the other half, and that way I was able to actually run a bolt through and hold it down. So let's see, let's close that, and let's simulate this whole setup and see what it looks like. So let's go simulate. Let's turn off transparency here. There we go. Sorry. Okay. So first order business, this is with a 1/4 inch flat end mill. Is the 2D adaptive pocket. And then it's doing another clear to get to the bottom where the pegs are. So I did that all in 2 passes. Oh, we kind of skipped through that really fast. slow this down. Okay, then I did the trim on the outside. Then I came in with another operation to do a finishing pass right here on this outer wall to clean up any steps from my 1/4" end mill. And then it's also doing a finishing pass on the outside of all of the standoffs. And then once it's done with that, it's going to do the rough contour on the front side. So that's just going to go all the way around. I want to say about 1/4 inch deep. Now the reason why I left it there is because remember I have a tapered bottom. So if I cut all the way down, then I would end up, by the time I mill the backside of my part, I would have nothing left to hold on to. So I'd have no opportunity for tabs. So that's why I left it there, and I'll show you, it might be able to be more visible when I get to the other operations. So let's move on to the next step. Now this is still with a 1/4 inch flat end mill, and let's simulate this. And this is still on the same side. Oh, I need to slow that down. Okay. It might be kind of hard to tell, but it's basically another finishing pass. Actually, let's simulate both of these together so you can see it. Okay. Let's go to right here. Okay, so that's where we left off, sorry. And then once it's done with that, it bores the holes. And then I did another finishing pass here because at this point I took my metal plate and I needed to make sure that it fit in there. So I left myself an extra finishing pass that I could adjust just in case the fit wasn't quite right. And in this case it wasn't, so I took a little extra amount off, and that's what this finishing pass is for. And then this is actually really interesting. So now what I did was I gave myself the taper on these. Now the proper way to do this would be with like a chamfer bit or a round end mill. But I chose to do it with a flat end mill because these features are so small that you're never going to be able to see these ridges. So I ended up spiraling down, cutting a small chamfer on the end of each one of those. And the reason that chamfer was important is because the part of my circuit board where it was touching was only as round as this green surface right here. I couldn't have the full diameter go up, otherwise it would hit some of the circuitry. So that what was cool about that is that allowed me to not have a tool change. So I could do all of that without a tool change. So we're still working with the same bit, and I haven't re-zeroed the part yet. And then it's going to come through, do that to each hole. And then lastly, I did one more finishing pass because this wasn't measuring correctly. So then I came in and did that as well. I had one more finishing pass just to tidy that up. And so that's what that operation looked like. Now that's the entire front done at that point. Let me pull this back up real quick. We'll go straight to the end. I didn't simulate both. There we go. Simulate. Go all the way to the end. And this is essentially what, let's call it operation 1 is. We did almost all of it with one end mill and 1 0 of our work offset. We only did the very, very beginning with an 1/8 inch. We swapped out and we did the rest of it with a 1/4 inch end mill, even though we could have done a tool change. But now we're set up to go ahead and flip the part over. So let's go to the next setup. And let's show this. Okay, so I'm going to simulate this one first so you can see what it's doing. So we've got the same thing where actually I changed work offset to the middle for a reason later on I will tell you about, but it actually should be right here in this corner. But I will explain why I did it in the center later. So what it's going to do is it's going to clear out most of the material we need off of that backside. So that way our round over, or not our round over, but our round end mill or bullnose end mill has very little work to do. So let's get through that. Okay. Still clearing that out. So it's doing it in steps. And right now it's pre-contouring the backside, so that way the round end mill has space to come down and travel up and down the part. So I needed to clear out this material. Now that's why I said on the back side, or on the front side that we just finished, I only went partially down with the contour, because with this contouring the backside, I had to think about how am I still going to hold on to that part. And so I have like, you know, maybe 1/4 of an inch of material here still holding on to that part, even though this is now contoured down. Okay, and now it's going to go to its 3D toolpath. So now I did my second tool change to my round over bit, or not round over, I keep calling it that, my round end mill. And I did a scallop toolpath, so it's going around the perimeter each time, stepping up a little bit Z and in, and offsetting both an X and Y, so that it's going to clear out that material. And I can show you a video while this is going on the screen here. And then that's my operation. So this is what I was left with the back. So essentially I've got one big tab right here, and the backside's done. So now all I have to do is take the part off, cut off the tab, take it over to my router table, and flush trim that off. Now at this point I was pretty confident that everything was machined correctly, and so I went ahead and took off my part, cut it, flush trimmed it like I just said, and then it dawned on me that what had happened is my CNC had lost some steps in the stepper motors. And so I actually had, let me pull up the design here. So I had originally I think it's 1/4 of an inch. Yeah, 1/4 of an inch wall right here. But on one side I had like 3/16. And then the other side I had like 3/8. And I didn't notice it when it was cutting because it was a long operation and I had stepped out for a minute. And when I took it off, I was like, oh no. And I had just cut off my dowel pins and was like, how in the world am I going to get this back on my CNC and trim this back up? Or do I have to start all the way over? Because this is a nice piece of wood and I just spent all this time machining it. And I was like, oh my God. So this is when I kind of learned my lesson about making sure I'm diligent in my setups, making sure that I'm not being too aggressive with my cuts and I'm not losing steps or anything like that. And so what I ended up doing was adjusting my model. So I found this was going to be the easiest way to do it. Let me see if I can find that other model. It's slightly narrower. So if I hide this one, you can see that I made the exact same model, but I made it about a 1/16 of an inch offset inside. So that way I didn't end up with a 1/4 inch, but I ended up with 3/16 on all sides. So that presented a big problem because now I didn't have the correct alignment, right? My dowel pins were cut off. So if I would have caught that ahead of time, I could have kept it on the CNC, kept my alignment, and gotten a perfect result. But what I ended up having to do, which was infuriating, is the only way I could machine that is from this orientation. Right? So I had to machine it from this side with no tabs or anything, and I had to hold on to the part somehow. But I can't exactly clamp down onto the back of the part because it's pretty thin between these two sections. I want to say it's like 1/8 of an inch, and so I didn't want to put a lot of pressure on there. and then I can't squeeze it from the sides because it's now hollow, right? And I also needed to cut the full perimeter. So I needed access to all sides of this model. So what I ended up doing was the old super glue and blue tape trick. So what I did was I applied some blue tape to this rim right here, and then I taped down onto my wasteboard, applied some super glue, like spray CA glue, and then stuck it down as close to perfect alignment as possible. Now, thankfully, I had my my jig, so let me pull that up. So I used these corners, actually not these ones, because now it's smaller. I used these inside corners right here where my model was, and I tried to line that up perfectly. And with that, I was able to basically run a new operation and trim the outside, and I narrowed that in, and I was able to get a decent result. I almost lost the entire project because I wasn't paying attention. And so both a little bit in my cam and in my setup on my CNC. So that's why I ended up setting my 0 point, because I came back in here and the only thing I could really zero off of at this point, right, because I didn't have that perfect alignment anymore, is I needed to measure off of the model itself to hopefully guarantee that I was in center, because this reference point is only good if I'm lined up with these dowel holes. But since I'm no longer lined up with the dowel holes, I had to measure off the part itself. So that's why I went ahead and made a 0 point, tried to line it up with my fixture as close as humanly possible, and then I zeroed from the outside of my part to the other side in the middle, went in Y and back into the middle, and that's how I got my 0 point. All right, so before we call this video a wrap, let's go ahead and head over to my toolbox, and I will show you guys what the fixture looked like and what the finished keyboard looked like, and we'll talk about any last takeaways. I'll see you over there. All right, welcome back to my toolbox. So here's the actual fixture that I used for this project. I kept it around in case I ever wanted to make another one of these or make some modifications to my existing one. And here's the dowel pins. So I use 3/8 precision ground dowel pins. They're accurate to within about 1/1000th of an inch, and they're more than strong enough to hold up to everything, and they're basically infinitely reusable. I've got them in a bunch of different sizes laying around the shop, but essentially these are the long ones that go into the fixture that hold the part, and they require a little bit of force, but with a little bit of effort or muscle, I can pull these out. There we go. So I can pull those out in case I need to run a new set of stock on top. So they're not permanent, but they do require some force to get in and out. And then I've got these smaller ones, which on my toolbox sit proud of the surface, but when they're in my CNC, they sit flush with the top. So that way they stay out of the way of my cutter just in case anything bad happens. And so these ones take much less force to install, but they still have basically no slop in them, but I can pull them out with ease. And that was kind of the ideal scenario for me, so that way I could actually take the fixture off quite easily. And here is the finished keyboard. So it's kind of a non-standard layout. It doesn't have a numpad, which is kind of an oversight on my part, because being someone who CAD models a lot, not having a numpad is kind of infuriating. So that is actually one of my future projects, is to make a matching numpad to go with this keyboard. It might be kind of hard to see from this angle, but you can see the little offset that I had, where originally the keyboard would have been flush with this outer edge of the fixture, but because I ran into that little problem, or big problem, it is a little bit smaller on the walls than I wanted, but it actually turned out really nice, and I'm quite happy with it. Now, the reason why I made this video is because it's really important to think about how you're going to model your part, but it's also almost more important, if you're going to be making it, to think about how you're going to manufacture the part and what do the steps in that manufacturing process look like, and how does that impact your progress through the model? And so you have to think about how you're going to hold on to the part, how you're going to zero your work offsets, how, if you're going to flip it, how you're going to keep it in alignment, how, if you do take it off and you cut something off, is that going to cause unrepairable damage that you're not going to be able to finish the project? So you have to think through the process start to finish and structure your order of operations in a way so that way what you do in step 1 doesn't mess you up in step 2 or step 26. So an engineer I work with once told me that his goal as an engineer is not to never fail, but rather to fail as fast as possible. Because the faster we can learn from our mistakes, the faster we can get on to making cooler shit. I hope you guys enjoyed this video, and I'll see you in the next project.